Another easy one, linked list cycle. So yeah, I guess if you know the algorithm for it, it's a fairly simple one. You can use a tortoise and hare algorithm in which you have a slow pointer and a fast pointer. If the fast pointer reaches the end, then there is no cycle in the linked list. If they meet again, it means that there is a cycle because they're moving at a different pace. And essentially speaking, it's an infinite loop, so they're gonna run into each other again. So to make this nice and quick, let's actually, I don't even know if that's how you spell tortoise. If it isn't, I'm being super explicit here. Let's say, so whilst the hare dot next, I've never really named variables like this. I feel silly doing it, but you know. Well, as long as we get there. So what are you gonna do? So whilst it exists, so whilst it's not at the end of the linked list, we are going to increment them both. Tortoise equals and then we're going to increment this one by 2. So as opposed to next being the location of the next linked list in the cycle, dot next will be a pointer at the one after that. And then we can just say if tortoise is equal to equal and evaluate them to the hare, then we can return true. Otherwise, we can just return false. I got a call in a little bit anyway, so hopefully that's correct. All good. Yeah, fairly simple one actually, to be honest. A good problem to solve. Will get you used to actually handling the object for the linked list as opposed to, you know, pointers to specific values and whatnot. We evaluate them to the actual object as opposed to the value, because there could be multiple values within the linked list that are at different places. So we could have a linked list of like the number 7 3 times, and of course if we thought we're evaluating to value, that wouldn't work there because it would evaluate to true but wouldn't be necessarily an indicator of the cycle. So let's submit that. All good, all good. Yeah, the grind continues. All right, peace.